Hi, I'm Patrick Reagan. Welcome to the Network Routing and Router series of videos. In part 1, Routing and Router Technologies discuss what a router is and how it is an essential part of the network as it connects and routes between networks. It also discusses network address translation. As always, stick around for the practice questions at the end to test your knowledge and help you prepare for the A+ exam. If you find this video helpful, don't forget to click the like button. If you have not already, subscribe to the Pat Has Your Back channel for more tech training content and technical know-how. A network router is a hardware device that routes data packets between computer networks, directing the flow of information along the most efficient paths. Routers are OSI Layer 3 devices. Routers will connect individual networks together and often connect diverse network types such as LANs, WANs, copper networks, and fiber networks. Routers are critical components in both local area networks and wide area networks, including the internet. Routers are often represented by circles or disks with the 4 arrows pointing to and away from each other. Routers, or layer 3 switches that act as routers, will route traffic between subnets and LANs. Remember, the internet is just another network. Therefore, you'll need a router to connect to the internet. Typically, a layer 3 switch is more efficient than a router when routing between local subnets because they're optimized for high-speed packet forwarding and are typically used in environments where high performance is required. Routers, on the other hand, are designed for more complex routing tasks and often operate at lower speeds compared to layer 3 switches. Sites can be connected over the internet, which are connected via a router. The router will determine if the traffic needs to be routed over the internet to the other side. Routers determine the best path for data to travel from the source to the destination using routing algorithms. Routers maintain routing tables that store information about various network destinations and the paths to reach them. Routers can use static routing, which are manually configured paths, or dynamic routing protocols like RIP, OSPF, EIGRP, and BGP to adapt to network changes automatically. Routers forward data packets from one network to another based on the destination IP address. Routers use IP addresses to make forwarding decisions, ensuring the data reaches the correct destination. When a computer, network device, printer, or any other host on the network sends out packets, the sending host will first determine if the packet is being sent to the target host that is on the local network or if the target host is on another network. If the target host is on the same network, the sending host will send directly to the local target host. If the target host is on the remote network, the packet will be sent to the default gateway, which is a router link that is on the same subnet as the sending host. To determine if a packet is local or remote, it will use a bitwise calculation between the subnet mask and the source IP address, and the subnet mask and the destination IP address, which will isolate the network address for both. If the network address is the same, it will be sent locally, and if the network address is different, it will send to the default gateway. The router will then figure out the best way to get there. The router will determine if the target host is local to the router or if it's remote. And if the target host is remote, it will send to the next router that gets to one step closer to its destination. It will keep repeating the process by sending from router to router until it gets to the subnet that the target host resides on, which the router will then forward directly to the target host. Each router that the packet traverses is known as a hop. If a packet needs to go through 4 routers to get to its destination, the destination host is 4 hops away. Routers can divide a large network into smaller subnets, improving efficiency and security by isolating traffic. This segmentation helps in managing and securing network traffic effectively. Routers also divide your network into broadcast domains. Routers do not forward broadcast packets to other networks, thus limiting the scope of the broadcast domain. Similar to bridges and switches, routers divide a network into collision domains. Routers connect different types of networks, such as connecting a home network to the internet, and ensures that data can flow between them. They act as a gateway between networks, translating data as needed between different network protocols. By analyzing network traffic, some routers can perform quality of service or QoS, which prioritizes certain types of data, manage bandwidth, and ensure that critical applications receive the necessary resources. Routers often include built-in security features like firewalls, VPN support, and intrusion detection/prevention systems, which help protect the network from unauthorized access and attacks. Network address translation, or NAT, allows multiple devices on a local network to share a single public IP address, conserving IP addresses and enhancing security by hiding internal IP addresses from external networks. Routers can filter traffic based on access control lists, or ACLs, which are predefined rules allowing or denying traffic based on IP addresses, protocols, or ports. Many routers include built-in firewall features to protect the network from unauthorized access. Routers can establish and manage virtual private network, or VPN, which allows secure encrypted connections between remote networks or devices over the internet. Network address translation, or NAT, is a network layer routing technology that enables a group of workstations to share a single registered address. A NAT router is a device with two network interfaces, one connected to a private network and one to the internet. When a workstation on a private network wants to access an internet resource, it sends a request to the NAT router. Normally, a router passes traffic from one network to another without modifying the data. However, in this case, the NAT router substitutes its own registered IP address for the workstation's private address and sends the request onto the internet server. The server responds to the NAT router, thinking that the router generated the original request. The router then performs the same substitution in reverse and forwards the response back to the original unregistered workstation. The router, in essence, functions as the intermediary between the client and the server. A single NAT router can perform the same service for hundreds of private workstations by maintaining a table of the address substitutions it has performed. In addition to conserving the IP version 4 address space, NAT also provides a certain amount of protection to the network workstations. Because the workstations are functionally invisible to the internet, attackers cannot readily probe them for open ports and other common exploits. Port address translation, or PAT, is a type of dynamic NAT that maps multiple internal IP addresses to a single external IP address via port numbers, many to one mapping. When a computer connects to the internet, the router assigns it a port number that it appends to the computer's internal IP address, in turn giving the computer a unique IP address. When a second computer connects to the internet, it gets the same external IP address but a different port number. Corporations and home routers will use PAT so that the multiple computers and devices can use a single external IP address. In theory, you can have up to 65,535 devices using one address. However, in reality, it will be less because many times one computer may have multiple connections. If you install and configure a new router, which should allow access to the internet, you may need to configure network address translation so users can connect to the internet. Other advanced features include some routers can act as DHCP server, which automatically assigns IP addresses to devices on the network. Some routers can also provide IP helper, which forward DHCP broadcast requests directly to a DHCP server. Some routers provide port forwarding, which allows specific traffic to be directed to specific devices within the network, such as web servers or gaming consoles. Some routers can create a DMZ, which is used to expose the server to the internet while keeping the rest of the network protected. Some routers support load balancing, distributing traffic across multiple WAN links or connections to optimize bandwidth usage and provide redundancy. Routers with VLAN support can segment a network into multiple logical networks, improving security and reducing broadcast traffic. Routers often include monitoring and logging features, allowing administrators to track traffic patterns, detect anomalies, and troubleshoot issues. Routers often support redundancy features like Virtual Router Redundancy Protocol, or VRRP, or Hot Standby Router Protocol, or HSRP, to ensure network availability in case of failure. Routers can handle multicast traffic, sending data to multiple destinations simultaneously without duplicating packets for each destination. There are different types of routers. Home small office routers typically used to connect home networks or small offices to the internet. They often include integrated Wi-Fi access points, Ethernet ports, and basic firewall capabilities. Enterprise routers are used in medium to large organizations where they handle a high volume of traffic and offer advanced features such as advanced routing protocols, load balancing, redundancy, and support for multiple WAN connections. Enterprise routers are often used in corporate offices to connect multiple branch offices and manage large-scale networks. Core routers are high-capacity devices used in the backbone of large networks like those operated by Internet Service Providers or ISPs. They route data within a major network and between major networks. Edge routers are routers that are positioned at the edge of networks, connecting internal networks to external networks like the Internet. They often handle tasks such as NAT, firewall filtering, and VPN connectivity. Distribution routers connect multiple access routers, which connect end devices to the core network. They are often used in large enterprise networks where traffic needs to be routed efficiently from different network segments to the core, such as to manage traffic between different departments in the core network. Virtual routers are software-based routers that run on virtualized environments or servers. These routers can be deployed on existing server hardware or cloud infrastructure. They offer flexibility and scalability in virtualized data centers or cloud environments, and are often used in software-defined networking or SDN environments. For example, you can use a virtual router to run in a cloud data center to manage traffic between virtual machines or between on-premises and cloud networks. Question: what networking device is a hardware device that routes data packets between computer networks, directing the flow of information along the most efficient paths? Answer: routers. Question: what OSI layers do routers operate? Answer: 3. Question: which device can act as a DHCP relay that will relay DHCP broadcast to a DHCP server? Answer: router. Question: technician is setting up a new router, configuring ports, and allowing access to the internet. However, none of the users connected to this new router are able to connect to the internet. Which of the following does the technician need to configure? Answer: network address translation. Question: a packet has a destination address that is located outside of the local network. Which of the following should be used to route this packet out of the local network? Answer: default gateway. For more information, refer to these sites. In summary, a network router is a hardware device that routes data packets between computer networks, directing the flow of information along the most efficient paths. Routers are OSI Layer 3 devices. Routers will connect individual networks together and often connect diverse network types such as LANs, WANs, copper networks and fiber networks. Routers, or layer 3 switches that act as routers or route traffic between subnets. Routers determine the best path for data to travel from the source to the destination using routing algorithms. The target host is on a remote network. The packet will be sent to the default gateway, which is the router link that is on the same subnet as the sending host. Routers can divide a large network into smaller subnets, improving efficiency and security by isolating traffic. Network Address Translation, or NAT, is a network layer routing technology that enables a group of workstations to share a single registered address. Thank you for watching this video. The next video will be Network Routing and Routers, Part 2, Routing Protocols, Part 1. If you like this video, click the like button, and if you have not already subscribed to the Pat Has Your Back channel. Thank you.